Hi, my name is Trace Pollock and I'm a senior at Carmel Christian School. I'm a member of an elite team of students who are participating in a very special STEM program. Our school is partnering with the Quest Institute for Quality Education's International Space Station Research Program. This exciting opportunity was founded by the Valley Christian High School, a private Christian school based out of San Jose, California. This school, in association with the Quest Institute, works closely with NanoRx, a company that commercially sends, in association with NASA, small, automated experiments to the International Space Station for a total period of 30 days. These experiments are designed to be used inside a microlab, a small plastic prism with a total area of 14 square inches and can only draw up to 100 milliamps of power. The experiment must be able to operate remotely within this module for the full 30 days. Our team consists of 10 students, 5 seniors, 4 juniors, and 1 sophomore. We are aided by 2 teacher mentors to assist through the experimentation process, though the team is primarily student-led. Within the team, each student has a specific role ranging from electrical engineer to public relations representative.
Our experiment includes a 3D printed microlab, a track, a carriage, and a stepper motor that moves the carriage along the track.
In our experiment, we're sending magnetorheological fluids to space. MR fluids are liquids that have magnetic particles suspended in a carrier fluid. We're sending a 3D printed microlab that includes a motor, track, and carriage to move a tube of MR fluid between 2 magnets. Also, we built a custom circuit board that will take pictures of the structure in varying locations in the microlab. On Earth, MR fluids are used as a barrier, such as in spinning core drives or a brake. We want to find out if the fluid is substantial enough to be used for the same applications in space.
When we started researching ferrofluids, the information we found led us to MR fluids. For the mechanical portion of our experiment, we researched different types of adhesives and epoxies that are NASA approved. For the electrical component, we concluded that an electromagnet would not be accessible due to the limited power usage that we have. Because we have a limited amount of power that we can draw, we had to research a supercapacitor to meet regulations. In addition, we researched applications of MR fluids on Earth and in outer space.
In our experiment, we originally wanted to use ferrofluids and MR fluids. We found that we didn't have enough space for both in the microlab, so we decided to use only 1 test cell of MR fluids. When we first started designing our experiment, we decided to use an electromagnet because we wanted to control when the fluid would be exposed to a magnetic field. After some research, we figured out it took too much power. We decided to use a permanent magnet, which caused us to change our experiment. This led to a construction of a new microlab that was able to move a carriage between 2 permanent magnets. We 3D printed a track and carriage. This carriage had a test cell of MR fluids on it and was propelled across the track by a stepper motor and a lead screw. And 3D printing all of these components to the microlab led to a smoother construction of the final product. Our final product still allows us to control when the fluid is exposed to a magnetic field by moving the fluid's physical position rather than controlling an electromagnet.
Our experiment we learned in a project-based setting, covering many different scientific fields. We learned how to design and 3D print our module using CAD. We also learned how to build and solder our own custom PCB board while writing a code to operate that board. With help from our mechanical engineer who constructed our microlab, we learned practical and detailed information about the scientific method and the engineering design process.
Some lessons we learned through our program were teamwork, practical engineering skills, and how to overcome failure. Teamwork will help us in the future because we have learned to work together and solve problems. Soldering, 3D printing, P-basic programming, and CAD modeling are all practical engineering skills that will help us prepare for a future career in STEM-related fields. As a team, learning how to overcome failure has taught us to be flexible when things do not go as planned.
The primary purpose and outstanding value in our experiment lies fully in research and development. We are striving to learn as much as we can about how MR fluids work in microgravity so that we can continue to further develop these opportunities. We, the Carmel Christian School ISS Research Team, are excited to play our part in expanding the use of MR fluid technologies into microgravity.